Hi, it's US Radio Guy. I'm going to talk to you today. I had three questions on my last video that really didn't have to do with the last video. They wanted to know how I did the day-night combinations on the generated animations that I make and post onto Twitter, Facebook, and Reddit, and other places. Well, I got one I called one up today, made one for the last 4 days, and I just have it playing in the background. You can see the day-night transitions. There's shadows right here. You can see these fall across the mountains as the sunlight goes through. If you look in the bottom here, you'll see a couple of flashes that pop up. Those I have described on my website. This is sunlight glint, basically, that's hitting, there goes one there, sunlight glint that's hitting the GOES spacecraft. It happens about 4 times a year, and I have a total description of what those are written up on my webpage that I'll talk to, or you can find out, and I'll put a link there in the comments below the video here. So how do I do this? Let me pause this. So this is done with a couple of different pieces of software. In addition to ImageMagick, FFmpeg, a lot of the command line scripting that I use in a batch file, but in particular the two key ingredients in this recipe is the software package called Xplanet, which is at xplanetsourceforge.net. I'm going to see if I can turn on my cursor here, highlight that up a little bit. So there's I'll put a link to that in the comments as well. What Xplanet does is, it's an older piece of software. You can run on i386 machines, so it runs just as well under Windows 7, 10, 11 that I'm using. But it creates artificial planets, imagery of artificial planets. You can see there's some examples here. Bring one up. Let's see. Yeah, there's showing different ones, how this one was created. This one actually was done to show the eclipse of December 4th, 2002. So you can see the shadow there coming across the Earth, what that looked like. It's really quite a capable piece of software. It's older. It is done with command lines. There is no graphic interface for it, so if you're looking for that, this is not the one you want to be using. And then the other key ingredient in that recipe for creating that is Matt Painter's Sanchez software. And if you haven't used it yet, it's a really nice piece of software. Its original intent was to take IR imagery, which is grayscale imagery, and then put a false color image underneath that to render a color view of the planet from whatever satellite you're looking at. And some people say, oh, that's not real. Well, I got to tell you, NOAA, EUMETSAT, JAXA all use a very similar system to this. They also have true color, which we're not able to get with HRIT, but they also use these static background images that were created by other polar orbiting satellites, and they're in a repository right now on NASA's site, and they're free to download. So you can see just a couple of the images that Matt has detailed here. Now, what's nice about Matt's GitHub page is he has a really nice wiki that explains how to use Sanchez for the various, whether it's Linux or Windows, and then the common arguments that are used, how to composite, how to make equal rectangular projections. And I'm assuming if you're using this, you know about Sanchez and you're comfortable in using it. If not, I would definitely try to use Sanchez for some simple imagery. Maybe just take one image, create a reprojection, or try to blend in 2 images, maybe 2 IR images, one from GOES 16, one from GOES 17. See if you can do that before you try even putting your toes into this night dark stuff, because it took me a while, a lot of head scratching to figure this out. So I'm going to be popping back and forth to show you kind of how the system works. So what I'm doing, and this is the end result of both, or this is just the end result of using Sanchez. You can see here it's generated a night portion based on time, a daylight portion, and then that night portion. And when those are all merged together, then of course you get a day-night view of the globe. Now, show you a little bit about that. We'll be popping back and forth between the scripts and the imagery here. I'm going to start out with Xplanet. And like I said, Xplanet is a command line utility, and they have all these things listed on their website. Oh, looks like, see, this is one of my automatic scripts polling up. It's heading out, grabbing some GRB imagery. Let me minimize that. Yeah, it's 12 o'clock, so that's when that happens. So Xplanet, I broke down so you can kind of see what all these different commands do, and I'll put both of these commands that I use for both Xplanet and Sanchez in the comments section of the video. So the first thing it does is you have to tell it what body you're looking at, and I'm picking Earth. So I have a file in my configuration to tell Xplanet what image to use to create that planet Earth. Now the reason you have to tell it Earth is because you could pick Neptune, Venus, Mars, the Sun, because it has the ability to place those accurately in space. So that if I wanted to generate an image and I wanted to use the Yale star catalog behind that, it would put Earth in the correct place at the correct time on the correct date, and use the Yale star catalog to put the stars behind it in the exact place they would be at that time listed. The configuration step tells the Xplanet what configuration file to use, and the configuration file that I'm using is called step. So Xplanet, just like Sanchez, needs a configuration file. They're done two different ways. Xplanet uses a configuration file like this to tell it what I am looking at to have the software do. And I'm just going to run down these fairly quickly. Magnifying, I'm not magnifying the image at all. I'm just using the imagery that I've chosen. The grid is the latitude longitude lines. You can print those out on the image if you want. I said false, so I'm not going to do that. The night map I'm using is one that I created using some NOAA imagery from Suomi NPP, and I made it darker because it didn't show up as well for me. The shade and the twilight. This is the amount of shade that is rendered further down here on the bump map, so that if the sun's coming across a set of mountains, it'll actually create false shade to give it a 3D look, and I'm setting it at 15. Twilight is the amount of night-day blend that is shown on the planet. The higher the number, the more the blend. I have it set at 7. It seems to be fairly accurate. I actually looked on solstice day and was able to figure out how many kilometers wide the shadow is on Earth, and 7 seems to be about right. You can enlarge it if you want to be super accurate for, say, equinox down in June 21st, but 7 seems to be an all-around good number. I'm not using any labels on this, so it's 0. The world map that I'm using is again in the configuration file with a size of 8,192 by 4,096, and these maps you can find on NASA's website, and I'll put a link to that. The specular map and bump map are kind of important for what I'm doing here, and I'll bring those up. So a specular map is a black and white map. There's no gray to it. It's just black or it's just white. So what it does in the software, it lets the software know where water is, so that when the sun is, or the planet is rotating around the sun, as the sun's crossing, you can just picture my cursor here in the green, as it's crossing, every time it hits one of these white spots with like these white lines, it's going to make a reflection, a sun glint, like it crosses Lake Ontario here, then it might cross Lake Huron, then Michigan, then over to the Mississippi. Each one of those generates just a little flash of light. It's hardly noticeable, but on the ocean you can see the reflection of the sun, you can see the shadow of the sun, and wherever it's black, it does not create any glint because that's land, and land doesn't reflect sunlight very well. And then this is the bump map. You can kind of see it's a grayscale map, and what it does, it allows, let me zoom out on this one. take it down to 15%. It allows Xplanet to figure out where the high points are and where the low points are, so that it can generate where the mountain ranges are. Like if I go down here to South America, the Andes Mountains here, quite clear. And what it'll do, in combination with that shade command in the config line, it'll actually create shadows on the mountains and the valleys to simulate the raising and lowering of the elevation. Now going back to this, I'm not using any satellites here, so I have it commented out. The Rayleigh emission. So Rayleigh scale is what the atmosphere does to sunlight as it passes through our thin layer of atmosphere. And you can change all these settings. You can see I do mess around with these. So I had it at 5. I may have changed it before, but I got it back to 5 now. This one was at 2. Now I moved it to 4. It's changing how that atmosphere looks to give it the most realistic look. And then it's looking in the file to see which Rayleigh configuration I want to use for it. And then there's colors for the atmosphere. I do have the sun and moon listed because if I were to pick a different longitude to do my projection from, the sun might be in the background or the moon might be in the background, and those are kind of nice to show. Okay, so going back to the configuration of that command line, we talked about the configuration file. The projection, I chose rectangular, and I need this because that's what later on in this script Sanchez is expecting. It's expecting a rectangular projection of the Earth that it can use to create that false composite. And where is that false composite? Right there, that's it. So this is just a sample of one of the frames that Xplanet is outputting that Sanchez will input and use as part of its composite image. Verbosity, that just says how much of the software do you want to see of all the details of what it's doing. And I set it to 3. I want it to be pretty explicit. I want it to tell me what it's doing while it's running. This is good for debugging. It doesn't really change the speed of it at all, but it lets me know that it's found all the correct files and it's processing properly. Geometry simply specifies the resulting image, and I'm matching it to that input image in the config file, which was 8192 by 4096. The date, I'm using a variable, so when it is looking as it's looping through this script, I have to tell it where it's starting from. So I went back, I think I started this thing on February 19th, 2003. So that's where it's starting its loop. So it's telling it start on the 19th of February at 05:0020 UTC. And then it starts compiling the images after that. The output start image, this is just a random number. I chose 1000. So I believe I have 292 images that I'm compositing here. So it's going to start with 1000 and then sequentially number up to 1292. Time warp is kind of interesting to figure out. The mathematics basically boil down to this is the time between each image that Xplanet will produce. And 1800 is the mathematical equivalent in Xplanet of 30 minutes. So I want to match my HRIT imagery, which comes in every 30 minutes, to the Xplanet created underlay at 30 minutes. The number of times I want it to run, this is pulled from another portion of the script. This is another variable. So I know there's 292 images. So I want Sanchez to run and generate 292 background images that I can use later on in Sanchez. Wait is 1. That's the delay time between each second that's each image that's generated. There is no 0. 1 is the minimum. And then it tells me also where to put the output. And I'm putting it out in Xplanet timed. Okay, now I'm going to run down and talk a little bit about Sanchez. Like I said, if you haven't used Sanchez, try it something simple, just like reprojecting an image or colorizing an image. Do something like that first before you get into this kind. Because I'm using a for loop here that is telling Sanchez to run multiple commands, and every time it runs a command to pick a different background image that is time matched to the original GOES 16 imagery that I have composited in a prior portion of the script. Now what I'm using here is a composite image of bands 2 and 13, and I have a section in Sanchez that tells it to look for that, and it knows to pull that composite, those two composited images that have then been combined into one, and use it to create the false planet reprojected image. So going down through that, so like I said, it's going through, and I'm going to bring up, if I can pop that up here. So this, going back to Xplanet, Xplanet is generating every 30 minutes. I just did a screen cap here. You can see that shadow is moving across the Earth. So every 30 minutes, it's generated an image with that shadow and the night view coming across the planet in this case. So there's the night view. You know, you got the city lights, the daytime. You can see the shadows that are forming here along the Andes Mountains. The shadows aren't as great anywhere here because this is in more the daylight, and then here you got the shadows going the other way on the Rocky Mountains with the city lights there. So I'm going to jump down and just talk about the actual Sanchez command line. So I do have variables in here, and you can look at these and kind of get an idea. The source that I'm using, this S in Sanchez, this is what you would normally put in. I'm using, I don't know, C:/GOES 16 images, and then that's where Sanchez would look for its images. I'm using a variable because, again, I have to pull a different image every time Sanchez runs in this loop. It's going to do one image, stop, do the next image, stop, do the next image, and each time it has to be told what image to use. So that's my variable to specify the path of that first input image. And then going a little further down, we have a couple of these parameters that it sets. This 0, the -B, the -F, the -T. So the first one is the haze opacity, which is this command. I'm using 0.4. The brightness, I'm using 0.9, and I'm forcing an overwrite of the image. That way, if I have any old imagery in the temporary file that I'm using, Sanchez knows to overwrite that image with the new image. And then I'm using a tint, and the tint is defined as a hexadecimal number. This is a type of blue that it seems to work good on the resulting image. Again, just like the source, Sanchez has to be told which underlay to use. So in this loop, as it's looping through, each time it does a command, this changes so that it knows, instead of using, say, the JPEG 1039, the next loop will be 1040. The next loop will be 1041, and so on and so forth. Because I want those time matched so that the shadow on the Earth matches exactly with what GOES 16 is observing from space at that exact time. Then down here's a couple more command lines. Verbose. Verbose, again, just like in Xplanet up here, verbose lets me run the program and see the resulting output of the program while it's running. And I'll show you an example of that here in just a second. I have the saturation level at 1, the haze amount at 0.1, and the resolution is at 4, which is, I think, the default value for Sanchez. And then lastly, this last command up here, the output, I have to tell Sanchez where to put those finalized images. So it's creating those composited image and then saving each single one. So let me pause for a second and I will load up how that kind of looks on the screen. Okay, I loaded up a screen grab of Sanchez doing its stuff. So I'm starting on this. It's already been running a little bit. Starting on this line, you can see it's got the arguments, the source, the opacity, the brightness, the forcing the file overwrite, the tint, the underlay. So it's looking for My original GOES imagery, which is band 2 at on the 23rd of February at 1220 Zulu, and it's matching that, which is what Sanchez outputted earlier, in this case 1059, and then the verbosity, the source, not the source, the saturation, the haze opacity, and the resolution, and then finally the output. And I'll just play these. So it's doing a loop. So that for loop is going back to Sanchez, saying, okay, pull the next image. So we're on 1061. It's going to look for that matching number. Now 1062 matches it with the GOES images, and then it starts generating these files. And if you look at the bottom here, where my cursor is, you'll see as Sanchez is working, it's popping up new files each time. I'm going to pause that here so you can see there's like just the edge of the night file, the next one, or night view. The next one is a little less. Then you get into the full daytime imagery, and then as the time keeps passing, that night image progresses more and more and more and more. And then those then are all used later to create the animated GIF that you see. So going back to just the 2 sample scripts I have, or these aren't even sample script, these are portions of a large script that I'm using. But I was asked specifically how to do the day-night. After it is done running, it's closed, and then it moves on to the next section of the script, which is for me adding a watermark to it and creating various MP4s that generates a couple different frame rates, so I can do a fast version or a slow version, and I will attach those to the end of this video. And so basically what this does, and I've got it listed here, it takes 2 sets of images and composites them together using the program Sanchez. So Xplanet generated the background, Sanchez is putting them together into the view, and then I'm using FFmpeg and ImageMagick to label, stack, and create a MP4 out of that afterwards. Now, I was talking about the full script that I use for this. This is it. If you look on the side, you can see it's, if I scroll down, it's kind of complicated. It's got a lot of different commands in it, and I'm not going to be going through all this. It's something I would say, I guess you'd call it expert level. Maybe someday I'll do a total tutorial on this, but I only wanted to talk about those 2 sections using the Xplanet to create the background image, and then my subroutine down below that creates the Sanchez imagery. So I hope this was as clear as mud. You got a little idea of how this works using 2 different software packages to create a rendered image of the Earth as 3-dimensional and not rotating, but with the sun passing over it in a day-night view. And you can see, I'm just going to show you that final version, play that here. And if you look down below here, you can see the dates changing. These are all time-stamped to when the image was taken, and then clearly the day-night shadow as it falls across. I'm going to pause it here if I can. If you notice at the bottom, let's see if I can pause it when that hits. Whoop, missed it. And see if I can go back a little bit. Right there. This is a sunlight glint. You may see those on your images. These happen about 4 times a year. NOAA does publish the eclipse times for these. This is actually when the sun, which is cropped out of what NOAA is sending us, and most satellites do this, not all. If we had level 1 imagery, we could see a little bit more, but it's cropping out the background because we don't need to, it's saving data by not showing us this. But that's the sunlight glint on the lens of GOES 16. And this, like I said, happens about 4 times a year, and I have a link that I'll post in the comments. I have a page on my website that shows this. So this is at a certain frame rate. You know, it's nice and slow. You can see all the colors brilliantly, the shadows as they come and go that Xplanet has generated. And then I'll pop up a faster one here. This one, so that one's running at about, let's see, 46 seconds. This one's going to be a little bit faster. So same view, but I have it running at a faster animation speed. Same information, same files, same timestamps, but this one's running at a slightly faster speed. Hope you learned something. Like and subscribe to my channel, and I will try to keep putting these out there. If you have any questions, ask me in the comments or over on my website at usradioguy.com. And I'm out. Thanks.